Welcome to The Explainer. So glad you're here with us today. We are literally putting on our safety glasses and taking a deep dive, a complete tour of the ultimate mechanical workshop. If you've ever held a beautifully machined part, or maybe admired a perfectly welded joint and thought, how on earth did they actually make this? Well, you're in the right place. Today, we're going to systematically walk through the workshop's departments one by one. We'll look at the exact tools that turn raw, stubborn metal into absolute precision engineering. All right, let's jump right in. So here's our logical workflow for this tour. We're kicking things off with marking and measuring tools, then heading over to sheet metal shaping. From there, we'll hit cutting and machining tools, followed by joining metals through welding, and we'll wrap up the whole shebang in the foundry with molding equipment. Section 1. Marking and measuring tools, laying the groundwork. Now, to build anything with precision, you absolutely need the right foundational layout tools way before a single cut is made. The steel rule, that's your primary measuring stick. Then you have the tri-square, which is vital because it checks the trueness, basically making sure you have perfect right angles. Now, think of the scriber as the workshop's pencil. It's the slender, hardened steel wire that you use to actually scratch or scribe lines directly onto your metal workpiece. For measurements that are kind of tricky to reach, we grab the calipers. They don't actually have numbers on them. Instead, they perform an indirect linear measurement transfer. You just capture the size of the object with the calipers and then hold them up to your steel rule to read the actual dimension. Oh, and for marking perfect circles and arcs, that's exactly where your divider comes in. Once you've scratched those lines with your scriber, you've got to make them permanent. That is exactly where punches come into play. And there's a really crucial difference between the two main types. The dot punch has a sharper 60-degree angle. You use it just to make very light indentations along your layout lines, so you don't lose your track while you're working. On the flip side, the center punch has a much wider, heavier 90-degree angle. You strike this one right before you drill a hole. That 90-degree divot acts like a perfect little seat for your drill bit, making sure it doesn't wander all over the metal when you power up the machine.
Section 2. Sheet metal shaping tools, bending and forming.
All right, moving into the sheet metal department. This is where flat, two-dimensional sheets magically transform into complex 3D objects. To start, you need snips. These act essentially as the heavy-duty scissors of the workshop. The way they're built, the blades actually pass straight through the handle to reinforce the top. This clever design allows workers to make incredibly precise straight or curved cuts right through some seriously tough metal sheets. Of course, once you've cut that metal, you have to convince it into its new shape. And for that, we bring out the impact tools. The ball-peen hammer is basically your general-purpose workhorse, and it's especially great for riveting. Then there's the cross-peen, which features a tapered end that is absolutely perfect for getting into tight perpendicular spaces. But I've got to say, the mallet is a personal favorite. Made of wood or plastic, it applies this really polite, smooth force. It lets you fold and bend sheet metal without denting or ruining the finish. Compare that to the raising hammer. That one is specifically built with the raw power to stretch and transform a totally flat sheet into a curved, bow-like shape. Now, here's the thing. You can't just hammer metal in midair, right? You need a solid backer, and that brings us to the stake. A stake is essentially the sheet metal worker's anvil, but unlike a standard blacksmith's anvil, stakes come in a massive variety of specialized shapes. You might grab a half-round stake to press a seam, maybe a taper stake to form a cone, or a beakhorn stake if you need to bend sharp square corners. They serve as the perfect rigid support underneath your metal while you hammer away from above. To round out the sheet metal bench, we have our gripping and joining accessories. You've got a parallel jaw vise bolted securely to the table to hold your jobs in place. Pliers are there to handle all the delicate wire bending and cutting. And block shears, they step in to cut metal stock that is just way too thick for your hand snips. When it's time to permanently fasten two sheets together, we rely on riveting, locking those rivets tightly in place using hand groovers and rivet sets to shape the ends perfectly round. Section 3. Cutting and machining tools, removing material. Stepping into the machining department, the whole philosophy changes. Here, we are dedicated entirely to removing material. We're literally carving away what we don't need until only the perfect part remains. One of the most basic, yet absolutely vital tools for this is the chisel. A good metal chisel has a beautifully beveled cutting edge, typically ground to an angle of 40 to 45 degrees, and they come in all sorts of profiles. For example, a diamond-pointed chisel is used to carve really sharp V-grooves, while a half-round chisel is exactly what you need to scoop out semicircular oil grooves inside of bearings. Let's look at how two complex operations compare. Drilling involves a rotating bit plunging right into a fixed workpiece. It removes bulk material to create a brand new hole. Simple enough, right? But a drilled hole is perfectly smooth inside. If you actually want to screw a bolt into that hole, you are going to need a tap. A tap is this screw-like tool with flutes cut across it. You twist it down into that smooth drilled hole and it physically carves the internal screw threads. So remember, you drill first and then you tap second. Now, there is a super common point of confusion in machining between drilling and reaming. So let's clear that up right now. Drilling, as we just mentioned, creates a completely new hole by tearing out bulk material. Reaming, however, does not create a hole. A reamer is carefully passed through a hole that has already been drilled. It removes just a tiny, microscopic fraction of material. Its one and only job is to leave behind perfectly smooth, highly accurate walls. Of course, in modern workshops, we rely heavily on automated, computer-controlled, or CNC machinery. Take a CNC lathe, for example, where a process called turning happens. Unlike a drill, a lathe spins the actual workpiece itself at really high RPMs, while a stationary cutting tool shaves material off the outside to create perfect cylinders. Now, if you need to enlarge a hole with absolute precision, you'd use a boring tool. A counterboring tool takes it a step further to increase clearance and align components. And if you're dealing with large, flat surfaces, a face mill is your best friend. It uses a spinning body loaded with multiple disposable carbide inserts to just chew through the metal face with incredible speed. It's amazing to watch. Section 4. Joining metals, welding, permanent fabrication. Moving into a bay defined by immense heat, one of the oldest and most reliable methods of permanent fabrication is gas welding. This relies on an incredibly specific workflow and, honestly, strict color coding for safety. The intense heat is generated by burning acetylene gas mixed with pure oxygen. The oxygen lives in a black cylinder, and the acetylene is in a maroon one. High-pressure regulators dial down the flow, sending the gases through heavily shielded hoses, green for oxygen and red for acetylene. These two gases actually don't even meet until they reach the internal mixing chamber of the welding torch. Finally, they exit through a specialized interchangeable welding tip where they're ignited to melt the metal. The modern alternative to gas is electric arc welding. Instead of a flame, this uses pure electricity to literally arc across a gap and melt the metal. To pull this off, you need a transformer to convert your standard wall power into specialized welding voltage. You also need an electrode to create that arc, and a heavy ground connection clamped straight to the metal piece to complete the electrical circuit. But most importantly, arc welding generates intense, severely damaging ultraviolet and infrared light. Wearing a proper welding helmet or at least a hand shield is an absolute, non-negotiable requirement. You have to protect your eyes. Section 5. Foundry and molding equipment. Casting liquid metal. All right, welcome to the hottest and easily the most dramatic department of any mechanical workshop, the foundry. This is where solid metal is melted down into a glowing, molten liquid and poured right into molds to create complex castings. Foundry work relies heavily on specially packed sand to create those molds, and keeping the molds perfectly clean before the pour is absolutely essential. That's where a classic piece of foundry equipment comes in, the bellows. It's a hand-operated leather air pump. Right before you pour that liquid metal, you use the bellows to gently blow away any loose or unwanted grains of sand from inside the delicate mold cavity. Here's a highly specific and honestly pretty interesting foundry term for you, gaggers. Because these molds are made of heavy, tightly packed sand, there's always a risk that gravity will cause the top half of the mold, which is known as the cope, to just collapse in on itself. Gaggers are basically metal skeletons. They are these bent pieces of wire or rod that are embedded directly into the sand to reinforce it. They securely hold that heavy, projecting sand mass safely in place so the mold doesn't cave in. Zooming out a bit, the foundry is home to some truly massive equipment. The rigid metal frames that actually hold all that sand are called flasks. You've got entire conveyor and mixing systems dedicated just to conditioning the sand. And to melt the metal, you need massive heat sources like towering cupola furnaces, pit furnaces, or crucible furnaces. When it's finally time to pour, heavy steel clamps and wedges are used to lock the flasks together so the explosive pressure of the liquid metal doesn't just blow the whole mold apart. And once the metal cools down, the rough casting goes through something called fettling. That's the rather grueling process of grinding, cleaning, and finishing the final part. And there you have it. We've done a complete walkthrough. From the precise, delicate scratches of a layout scriber all the way to the roaring heat of a foundry furnace. We've seen how flat sheets get bent into shape, how solid blocks are shaved down by CNC lathes, and how electricity can permanently fuse steel together. Every single tool in the mechanical workshop has a specific, highly engineered purpose. So I'll leave you with this provocative thought. Looking at the incredible journey metal takes from raw material to a finished, polished product, which workshop department would you want to master first? Thank you so much for joining me on this explainer, and keep building your knowledge.